It is my pleasure to prepare this video presentation and present it to the selection committee. I would like to focus on building services as it is my area of expertise. Traditionally, building services consists of four disciplines, namely the electrical services, HVAC services, fire services, and pipe services. For the design of electrical services, we consider three types of loads, namely essential loads, landlord loads, and tenant loads. Further, for tenant loads in an office, we may need to estimate the power consumption for lighting system and small power. Also, we need to design the cable routing for the various electrical loads. For the design of HVAC services, one of the very important considerations is the cooling load calculation. We try to study the solar radiation heat gain through window, conduction heat gain through wall, heat gain through equipments, as well as heat gain from occupants. This allows us to determine the amount of cooling required by the indoor space. For the design of fire services, we consider both the active fire protection system and passive fire protection systems. Passive fire protection system may include exit signs, exit staircase, exit doors. We not only need to provide the system, but also to make sure they meet the regulatory requirements. For example, the exit staircase should be of adequate width to discharge the occupants in case of fire. For the design of pipe services, we consider the plumbing services, that is, how much water needs to supply to the building. We also need to consider whether the drainage system designed has the capacity to discharge the foul water. As such, the correct sizing of water tanks and water pipes is very important. What I have mentioned so far is the conventional view of building service design. Approaching to the 21st century, substantial efforts have been spent to incorporate the concepts of green building or intelligent building into building service design. In the following parts of the video, I would like to share some of the examples with you. We may want to include daylight sensors in our lighting system. During the day, the sensor switches off the lights automatically since there is enough light from the sun. When the sun sets, the system will switch on the lights automatically. In this way, the power consumption of the lighting system can be reduced. We may want to utilize the double glazing window. An air gap is introduced between the two layers of window glazing for thermal insulation purposes. With this design, the amount of heat transmitted into the building is significantly reduced, since air is a very good thermal insulator. Also, the double glazing design can significantly reduce the noise penetrating into the building. We may want to add external shading devices on the facade wall to control the amount of sunlight admitted to the building. Notice that the position of shading device can be adjusted to allow different amounts of sunlight entering the building. We can allow more daylight to pass through the building during crowded days, and we minimize the amount of daylight passing through the building during sunny days. The concrete surface of a modern building absorbs heat from the sun and radiates it to the surroundings. So a significant portion of the building's unpaved area should be devoted to vegetation. Since plants are capable to convert carbon dioxide to oxygen through photosynthesis, this helps reduce the heat island effect, which is quite common nowadays. Currently, we rely heavily on coal, oil, and natural gas to generate electrical energy. However, since these resources will not last forever, there is a growing concern to adopt energies of renewable types. Solar energy, wind energy, hydroelectric energy, whenever possible. It is obvious the trend to make buildings green in the future. If I can take up the chance, in addition to the traditional building services knowledge, I hope to bring the new ideas of green building design to the universities, as well as to the young generations.